Actually, before moving on to the next problem, sometimes at the end of a video I really rush it just because I have that silly YouTube 10-minute deadline. And I want you to really understand this point here of why I picked the -2 and the +3. Because let me erase some of this and kind of show you what my thought process was. So I'm using the paintbrush tool. Let me just blank it all out. So if I just blank that out, and I could actually blank this out. I'm just blanking everything out, right? I could have just erased everything. But anyway, so let's say, okay. So the possible terms, once again, were 0 plus or minus 2 and 5 plus or minus 3. And I want to show you why I picked the lowest value here and the highest value here. So let me graph those points. That's my y-axis. This is my x-axis. And so, let's see. First I have the point 0, comma, plus 2 or minus 2. So this is, let's call this is 0, 2. This is 0, minus 2. 0, minus 2. And then we have 5. Let's say this is 5 out here. 5. And so this would be, let's say this is 3 up here. So let's say this is 5, positive 3. 5, 3. And then 5, negative 3 will be someplace around here. Just not scaled up. I have to squeeze at the bottom, but you get the point. 5, minus 3. So there's a bunch of lines that could connect this whole set of points, right? You have, I'm going to do them in different colors. You have this line. You have this line. You have this line. And then you have this line. Well, we want the highest possible slope, and you could probably just inspect it and say, well, that's the highest possible slope is the one that moves up the steepest, so it'll be this line. And this line and this line are negative slopes, so that's not a high slope. And the way I did it intuitively, I said, well, in order to have a high slope, I want as high a change in y as possible. I want to maximize my change in y. This is, let me switch colors. I wanted to maximize my change in y. Given my change in x. And that's why I picked the lowest y and the highest y. If I wanted the lowest possible slope, I would have picked positive 2 and negative 3, right? Hopefully that makes a little bit more sense. Let's see, let's do problem number 18. 18. Esther drove to work in the morning at an average speed of 45 miles per hour. 45 miles per hour is how fast Esther drove. She returned home. So this is to work. She returned home in the evening along the same route and averaged 30 miles per hour. 30 miles per hour. Maybe there was more traffic. From work. If Esther spent a total of 1 hour commuting to and from work, so 1 hour total, how many miles did Esther drive to work in the morning? How many miles did you drive? So this is a simple distance is equal to rate times time. Distance is equal to rate times time problem. But it's a little fancy. It gets a little confusing. So let's just say that d is the distance to work, right? Let's say d is the distance to work, and then we'll just solve for d, right? So if d is the distance to work, how far did she go in the morning? So in the morning we have the distance she went in the morning is going to be equal to 45 miles per hour. That's the rate, right? That's the rate. 45 miles per hour times the time. So let's just call that times t, right? That's what she did in the morning. She went 45 miles an hour times however long it took her. Then in the afternoon, she's going to go the same distance, right? She went the same distance. This time she went 30 miles per hour. 30 miles per hour. And how long did it take her? Well, this is the interesting thing. It took her a total of 1 hour to go to work and back from work. So if it took her t, let's say if it took her t hours in the morning, then it took her 1 minus t hours. 1 minus t. Actually, let's do it in minutes. Let's assume t is in minutes. So t is minutes. So then 1 hour is 60, right? 60 minus t minutes. Oh, no, actually, I have to stay with hours because these are all miles per hour. So forgive me. 1 minus t, right? Does that make sense? This one I think will make sense to you. 45 miles per hour times however many hours she traveled. It tells you how many miles she went. This time, you have her speed, 30 miles per hour, times the time she traveled. Well, the time she traveled in the afternoon is going to be 1 hour minus whatever she traveled in the morning, right? Because when you combined in the morning and afternoon, she traveled for a total of 1 hour. So if she, for example, if she took 15 minutes to go in the morning, then that means it took her 45 minutes to come back in the afternoon. Hopefully that makes sense. But these are the same d's, right? So we could set them equal to each other. So we could say 45 times t is equal to 30 times 1 minus t. And we say 45t is equal to 30 minus 30t. And then we can add 30t to both sides, and you get 75t is equal to 30. And then we get t is equal to 30 over 75 hours. And if we divide the top and the bottom by 5, we get 6 over, when 5 goes into this, how many times? It goes into, actually, yeah, no, we divide by 5. 5 goes into, see, 10, 15, right? I could divide by a better number than 5. Actually, I could divide the top and the bottom by 15. And you get 2 over 5, right? Or just take this and divide it by the top and bottom by 3. You get 2/5. So time is equal to 2/5 hours. And 2/5 hours, that's what, 24 minutes roughly, right? So the time is 2/5 hours. So we go back to the distance. So distance is, and remember, t is how long it took her in the morning. In the afternoon, it's going to be 1 minus this. So in the afternoon, it took her 1 minus this, which would be 3/5 hours. But let's just go back. The question is, how many miles did she go to and from work? So that's d. Well, d is 45 times t. T is 2/5. 45 times 2/5. 45 times 2/5 is d. Well, we can, it becomes a 9. Cancel with that, so it becomes 8. 18, I mean. 9 times 2 is 18. So d is equal to 18 miles. And we are done our second SAT section. I hope I didn't confuse you too much. See you soon.